Section 3.3 is the mole. So the mole is a unit of measure that we use since samples of substances typically contain a large amount of atoms. So like CO2 is not just one atom. And the mole is equal to the number of atoms in exactly 12 grams of pure carbon-12. So we use a number called Avogadro's number, which is 1 mole of something, always consists of 6.022 times 10 to the 23rd units of that substance. So, for example, we know that 1 dozen eggs equals 12 eggs, but 1 mole of eggs would equal 6.022 times 10 to the 23rd eggs. So that's Avogadro's number, which I've circled here in purple. So memorize that number, you will be using it a lot. Okay, so let's talk about an example here. So this example says determine how many moles and how many atoms are in a 10.0 gram sample of aluminum. So they gave us the amount of the sample, which is 10 grams. So we need to go from 10 grams of aluminum to moles of aluminum. So the abbreviation for moles is just MOL. So we can do that using the atomic mass of aluminum. So we don't really ever say average atomic mass because we know that all of the masses on the periodic table are average. So we just always refer to it as atomic mass. So 10.0 grams of aluminum. So if we look on our periodic table, the atomic mass of aluminum is 26.98. So we multiply to convert. So this is still using basically just a conversion factor. So 26.98 grams for every 1 mole of aluminum. So it's always per 1 mole. So if we do that math, 10.0 divided by 26.98, rounded to 3 significant figures, we get 0.371 moles of aluminum. Okay, so now we can take this number and figure out how many atoms of aluminum are in a 10 gram sample. And we can do that using Avogadro's number. So we take our 0.371 moles of aluminum, and then we know that Avogadro's number says that there's 6.022 times 10 to the 23rd units per 1 mole of substance. So for every 1 mole of aluminum, there is 6.022 times 10 to the 23rd atoms of aluminum. Alright, so basically now all we do is multiply the 0.371 moles times Avogadro's number, and that comes out to be 2.23 times 10 to the 23rd atoms. So that's our final answer there. And that's really it for the mole. And with practice, it will get a lot easier.